What you're going to be asked in the test is you're going to go prove that the angles in any triangle add up to 180. You're going to need a diagram, okay? So what you learn off when you're learning off these proofs is you learn off your diagram. It's the one thing you have to learn off by heart. The words and the letters you don't have to learn off by heart, but the diagram you have to, okay? Now, what I don't have learned of is I don't learn off the names, okay? So what I'm going to say is a triangle, and then usually when I do a triangle, I'm going to use the first three letters of the alphabet, A, B, C, okay? Now, for argument's sake, I'm not going to do it the same as the book, alright? Just to show you that I'm not learning it exactly the same way as the book. So instead of using A, B, C, I'm just going to use them in a slightly different order, okay? Just to change things up, because how would you know it's in that direction, okay? So you wouldn't. A, B, C, right? Now after that, what I have learned off by heart for this is that we say, it says given, okay? So what we say is given a triangle, and what goes in here is whatever three letters you used. So what did I use? So I used A, B, C. So whatever three letters you decide to use go in there, okay? And with angles marked. Now once again, whatever numbers you use for the angles within the triangle. And once again, I'm going to mix it up. Angle 1, angle 2, angle 3. Not exactly as the way it is in your book, okay? Because you don't remember. You're in a test, you don't remember, okay? Now, what you do have to learn off by heart is alternate angles. Now, you don't write that down, but you don't write it down just yet, but you write down alternate angles. And that's how you prove this question. Two ways to prove this question are alternate angles and straight angle. These are your two ways to prove this. Okay, so let me begin. Angle 4 and angle 5. Okay, so we are looking to prove that angle 1 plus angle 2 plus angle 3 equals 180. How did I know that? The angles in the triangle, 1, 2 and 3 are in the triangle, therefore they must equal 180. Once again, you don't have to learn, you just, in a different solution, if you had that called angle 2, 3 and 4, you'd then say angle 2, 3 and 4 equal 180, okay? Construction, what did you construct? You drew this line L. You started off with the triangle, okay? But you know what you did after you drew the triangle? After you drew the triangle, you drew this line here. Do you see that? And now colored it in green. That's the line you draw after you draw the triangle. So given means you're given the triangle at the start, and then construction is draw line L through, what point does it go through? Point C. And then what did we do after that? We marked two new angles, because we haven't mentioned 4 and 5 anywhere yet. And then we marked the angles 4 and 5. Is that alright? Now, once that's done, what you're going to do next is you're going to do the proof. Can anybody tell me what did the 3Ds add up to? Angle 4 plus angle 3 plus angle 5 equals 180 degrees. And what's the reason? Straight angle. Okay. Now, once that's done, okay, what can we say about the relationship between angle 4 and angle 1? Angle 4 and angle 1. Sorry? Angle 4 equals angle 1 because it's Z-shaped, but the other word for Z-shaped is alternate angles. And likewise, angle 5 equals angle 2 for what reason? Alternate angles. And what do we now change angle 4 and angle 5 for? Angle 1 plus angle 2. So angle 1 plus angle 3 plus angle 2. All of these angles are located within the triangle. We now know that they equal 180, and you've proven your proof. Is that okay? Next one. Each exterior angle of a triangle is the sum of the interior opposite angle. Right? So in this one, there's a given. So we once again draw a triangle. How do I know to draw a triangle? Because it says the word triangle, okay? So we draw a triangle, and then we gotta draw a line straight through. Okay? Now, what you might say is what you're given, okay? So we call that A, B, and C. Name some angles. 1, 2, 3, and angle 4. Okay, what are we given? We're given a triangle ABC with the side BC. Do you know what I mean by the side BC, lads? The side BC is here, isn't it? Yeah. And we extended the base to a point D, with the side BC extended to the point D. Now, what we're saying next is to prove, okay, so extend the point D. Oh yeah. I forgot one thing, okay. I'm going to change this to prove, because there's no construction part of this. And we'll just continue on our descriptions. The angles marked. So the angles marked, you got to talk about the angles we put in as well. 1, 2, 3, and 4. So you're basically describing your diagram, is what you're doing. Are also given. What are we asked to prove, guys? Anybody tell me? What angle equals what angle? Angle 1 plus angle 2 equals? Anybody? Angle 4. Now how are we going to do that? To remember this off by heart is you got to learn two things. Triangle and straight angle. That's exactly how you do this proof. So let me tell you. Angle 1 plus angle 2 plus angle 3 equals 180 degrees. Reason? 3 angles, and you gotta write down your reasons. 3 angles in a triangle add to 180 degrees. Are we happy with that? Yeah. We good, Mark? Okay. Second one. Angle 3 plus angle 4. Anybody? Angle 3 plus angle 4. Why? Okay, straight angle. Thank you. Now, finally, after doing that, what can we do next? Angle 1 plus angle 2 plus angle 3 equals angle 3 plus angle 4. What's the reason for that? They both add to 180 degrees. What's common to both sides? Angle 3, so therefore angle 1 plus angle 2 equals angle 4. Proven, right? Yeah. Proved. Okay, move on. In a parallelogram, opposite sides are equal and opposite angles are equal. So the converses, okay, and the converses. So let me see. Okay, so what do you think we're going to draw? Take a wild guess what we're going to draw. Going to draw a parallelogram, okay? And we're going to leave the parallelogram without the construction starting off. So we're given a parallelogram A, B, C, D. Once again, I'm not going to pay any attention to the order of the letters. Capital letters as well, by the way. Okay. Now, yeah, they changed that from when the book was made. So capital letters all the way, okay? Now, given a parallelogram A, B, C, D. Is everybody happy with that? Because it's the only thing we described, isn't it? Now, what are we trying to do? We're trying to do to prove, okay? So I'm going to prove the opposite sides are equal, okay? So I'm going to start off with the opposite sides are equal. that right?
Yeah.
So, opposite sides are equal. To prove that AB equals CD and anybody else? AC equals BD. Everybody happy with that? Now, I'm on the construction part. What's the construction part? Draw a line. Yeah, where is it? Draw the diagonal. Draw the diagonal AC. Why is it AC, guys? Going from here to here. Now, once I do that, what do you think I should do next? Marking angles, right? So angle 1, angle 2, angle 3, angle 4. Draw the diagonal AC and mark the angles. Okay, 1, 2, 3, and 4. Now, guys, to learn this one off by heart, okay? The one word you're going to learn here is ASA. What does ASA mean? Angle side angle. When you prove an angle side angle relationship between two triangles, you prove that the two triangles are identically sized. So what I'm trying to do here is, you've imagined this is a green triangle, and you've imagined the other one as a pink triangle here, and they both have a common side. So green triangle is the top one, the pink triangle is the bottom one. I had to prove an angle side angle relationship between the two of them, and if I manage to do this, it means that both triangles are identical. Happy enough with that? Yeah. Okay, so here's what I'm going to do. We're going to start off with the angle, okay? And we're going to write down both. When I'm doing an ASA, an SAS, or an SSS, I tend to write both triangles at the top. So what are the label of the two triangles? The first one is ABC, and the second one is ADC or CDA. Okay? Now, we have to do ASA. ASA. Let's start off with an angle. Pick an angle in ABC. Pick an angle in ABC. Angle 3. Start off with angle 3. Angle 3 is equal to anybody? Why is it equal to angle 2? Alternate angle, okay? We've done our first A. Now we're doing S. What side is guaranteed to be the same length in both triangles? No, that's what you're trying to prove, so you can't use that. AC is guaranteed to be the same in both triangles. Why is that, Owen? AC being the same in both triangles? Because it's in both triangles. The whole point of the proof is proving the opposite sides are the same. You can't use that as part of your proof. Okay, so guys, you are right. Most of you are right. What you're saying is, look, AB is the same as CD, but you're asked to prove that. So if you're asked to prove it, you can't use it as part of your proof. Okay. Now that that's done, okay. What's our other angle? What's the other angle we didn't choose? Angle 1 is equal to angle 4. Reason? Alternate angle. By the way, I forgot this one. It's a common side. Now, what do you write down after you prove ASA? Triangle, ABC and ADC are what? What word? Begins with C. Congruence. Hence, what does this mean? Hence, AB equals CD. And what's the other one after that then? AB equals CD and BC equals AD. Okay, there you go. Next one. The theorem of Pythagoras. Okay. Now, what do we always use for Pythagoras' theorem? What type of triangle? So, therefore, draw yourself a right angle triangle. Okay? We can see that the right angle's up here. Label it. What do you want to label? Probably go for the first three letters again. I'll mix it up. A, B, and C. Now, what are we given? What we're given is, what did we start off the question with? Thank you. A triangle ABC, and it's a right angle where the angle ABC. Do you know what I mean by ABC? A to B to C is what type of angle? It's 90 degrees. Okay. What are we trying to prove? AC squared. The hypotenuse equals plus AB squared. Yeah, good man. Now, construction. Make it look like what you've done there. Okay, so what you're going to do is you're going to draw a line going from B down to AC. Okay, so that's where you're going to draw. So you're going to draw a line starting at point B that is, anybody, perpendicular to, what's a perpendicular to? Do you understand what I mean by perpendicular? What does it go at right angles to? It goes at right angles to the line AC. To the line AC. Okay, and then what angles we're going to do? Mark the angles. Now, what angles do we mark? We can call that 1, this one 2, this one here 3, and this one here 4. So now every angle is, sorry, that's a 2 there, just so you know, okay, 2. Now, once again, I'm not following the exact recipe of the book. I'm just marking in the angles, I think. So, how do we do this one, okay? So, consider triangles. What are the two smaller triangles we made? Two smaller triangles we made are, we'll call this point D. Anybody? ABD and B. Oh, sorry. I remember this now, how I learnt this off, okay? Do you know when you make your two triangles, your two smaller triangles? Yeah? What you do is this, okay? You always do, you do the left triangle with the big triangle. Following that, you do the right triangle with the big triangle. So there's a combo there, okay? So it's considered the triangles ABD and ABC, okay? You want to prove they're similar. So the way I learnt this off is you don't write this as part of the question. I said left big, prove they're similar. Right big, prove they're similar. And then you're going to try and plug it into this answer here, BC squared and AB squared. Let me show you what I mean in a second. Okay? So, we're looking at the angle ABD, okay? Now, we're going to draw them both out separately. So, ABD is this one here. So, it goes ADB. This is angle 1. That's angle 2. And that's a right angle. Now we're going to draw out ABC. Is ABC. Now, we got to prove they're similar. What are similar triangles? Can anybody tell me? Anybody know what a similar triangle is? Exactly. So if I was to do this for a triangle, if I said, oh, here's my first triangle, there's my second triangle, you can see that the triangles are in the same shape. Same shape means that all three angles are there. Same shape means red angle here equals red angle here, green angle here equals green angle here, and then finally blue angle here equals blue angle there. That's similar. They can have different lengths, so example 5 and 10, 6 and 12, 8 and 16. One of them is exactly twice the size of the other one. So same angles, different lengths. You got that? Okay, so what we're going to do is we have to prove that the two of these are similar. That is the whole point of this question. Okay? So any of these have to do that. Angle 1, and this one is a right angle triangle, yeah? And then this one here is angle 4. So, using ABD and ABC, what we're going to do is this. We're going to say that angle 1 equals angle 1. Reason? Common angle. Angle, we have no number for it, so we're just going to call it angle ADB. Everybody see angle ADB? A to D to B. What one does that equal? A to B to C, because they're both 90 degrees. Therefore, what does that mean? Because both triangles add up to 180, it therefore must mean that angle 2 equals angle 4. Reason? Angles in triangle must add to angles in a triangle must add to 180 degrees. If one triangle has two angles that are the same, the other triangle has the same two angles, it must mean that the third angle is the same amount, because they both have to add up to 180 degrees. Okay? Now that that's done, we know that hence ABD, triangle ABD, and ABC and ABD are, what's that word? Similar. Similar is different than congruent, because it's the same size. So once we're done with this, we use the rule for similar triangles, okay? In a similar triangle, this blue angle here is the same as this blue angle here. The green angle here is the same as the green angle here. So we have to pick a side that is common to both. So what side is common to both, guys? AB is common to both, isn't it? Okay.